So the big picture for this lesson is non-renewable resources. A resource that is non-renewable means it is used once and then gone. The non-renewable resource we use the most of is oil. Our society is very dependent on oil right now for energy. And you can see the red line here, how there's been an increase in consumption over the years. And this is from 1997 to 2019. So for a non-renewable resource, you want to determine how much is available. And you also want to predict how much time is left until that resource runs out so you can make plans to do other things. And there are two different types of models. One is a static reserve model, and the other one is an exponential model. So the static means that you're going to be using the same amount of the resource each year. As an example in the lesson just of withdrawing money, and since you're withdrawing money, you're not putting the money back, so it's considered non-renewable. Although if you're earning a really high interest rate, you could complicate the situation a little more. But let's just assume right now that you just have $750,000 and you have an interest rate that equals inflation, so you're not going to worry about all that. So if you spend $35,000 per year, how long will your savings last? So you divide $750,000 by $35,000 and you get 21.4 years. So that's a static consumption model. Now in terms of our society's consumption of non-renewable resources, typically the consumption is increasing over time, and that's a problem with oil, is that as societies become more developed and crave more energy, we become more dependent on oil, especially in terms of automobiles. So the amount of oil being used is actually increasing over time. So there's an exponential reserve model as the amount of use compounds each year. And this is a much more complicated formula. You can see natural log is in there, both the numerator and denominator. And capital S is supply, capital U is initial rate of use, and the R is the rate of use increase each year. So you would need all these numbers, and then you can calculate the number of years that the supply would last. And here's that money example again. And let's say in this case the inflation rate is 2% greater than your investment earnings. So you're actually going to be consuming 2% more of the money each year. So in that situation, your money will only last 18 years. So you can see how if you have exponential consumption, the amount of time that your resource will last is going to decrease. So that's what you're going to be doing in this lesson. You're going to be calculating static reserve and exponential reserve of non-renewable resources. That's the big picture.